project in the domain of machine learning and evolutionary computation. He has served as program chair of International Conference on Big Data, Machine Learning and Applications (BigDML 2019) and currently serving as organizing chair of BigDML 2021. He has served as General Chair of 25th International Symposium Frontier of Research in Speech and Music (FRSM 2020) and co-edited Proceeding of FRSM 2020 to be published as book volume in Springer AISC series. He is currently editing 3 books titled Health Informatics: A Computational Perspective in Healthcare, Principle of Social Networking, The New Horizon and Emerging Challenges, and Principle of Big Graph, in-depth insight in different Springer and elsewhere book series. Now, may I request you, sir, to start your keynote presentation?
Thank you, Shakshi, for your nice introduction, and thank you, Dr. Doran, for inviting me. Is my screen is visible?
Yes, sir.
Yeah. Okay, today's talk, I'll be focusing on how social media influences our day-to-day life, and then I'll be moving towards how the group formation in the social media, how it actually influences or involves these influences to change or edit in some way our opinions or sentiments about anything, any topic or any event. Now, why do we study social networks? Picture tells 1,000 words, you often we say. So here I'll be just going through some of the small snippets of news articles that were published recently. So here you can see the that was one news. It was actually on January 2021. There was a news regarding Twitter suspends Trump's account permanently. And why is it so? Because of some political events there. And now recently you can see Twitter says that Donald Trump's account owned. Sorry.
Gaurashyam, please mute your mic. Gaurashyam, please mute your mic. Okay, please go ahead.
Yeah. So Twitter says this is five days ago.
Can you please share your full screen? And we are still in the first slide. Is it right?
Yes, it is right. So okay, I'll be moving to next.
Okay. Fine.
So I'm saying, so this event that I was talking, the Twitter suspension about Trump's account, this was about 1 month ago. So now recently you can see another news event comes, that is Twitter says that Trump's account won't ever be restored. So that is one news. Now another news, this was on 2020, 2020 November. So what happened was there was an event. That event actually happens to be in Ladakh, but Twitter actually misplaced that as a Chinese land. So huge political events, ruckus were there. Later on, the Twitter has apologized for this event. So what are these things? These things tells us about the politics, how the social media, the Twitter, normally Twitter is in Twitter, the politicians are very active, and any political event actually it happens to be in the Twitter, and those affects the political events. Now here also currently the elections are going on in Assam and West Bengal and other 5 states. So this you will see that how this social media actually affecting those things. Now another thing, this is about the social network parlor. So you might have already aware of this thing that last month, like in the last month in US there were some violence. So for that the social media site, that is Parler, was found to be responsible where actually these things were shared. Now you can see here the Apple and Amazon suspended the Parler social networking app. Now the question is, this was on the social networking side. Why this Apple and Amazon are suspending these things? Because you see these things, these tech giants, these are actually providing services to that social networking app. So they fear that their business, actual business, may be hampered due to this event. So therefore, they suspended their event. Now another thing, you see, you are aware of about recent event regarding the Signal. So WhatsApp were having some privacy related issues. So recently we have another similar kind of social networking app, Signal. So you can see these lots of discussions were going on whether the WhatsApp will be replaced by the Signal. So most important thing here was, so you see here the Elon Musk also had tweeted regarding this, and he kind of asking that to use of Signal. So what are all these things? So you see, if the Signal kind of replace that WhatsApp, yes.
Are you still in the first slide or are you moving?
Yes, I am in the 7th slide.
Oh, so it is still, we are still in the first slide. Can you please share full screen and then, yeah, we are still in the first slide, please. Yes. Okay, now we are in the 7th slide.
Okay.
So if you can do the full sharing of the screen, then it may probably.
I am on the full sharing mode only.
Okay. Okay, now please just go down next slide and let's see it is moving or not.
Is it moving?
No.
Which slide currently?
Yeah, it is still in the 7th slide.
But in my system, it is moving.
Oh, that's why. Can you just make it full, or there are 2 options, I think, for a window or the entire screen.
Is it okay if I present like this?
This is slide number 7 only. That is fine, but if we can go to, yes, yeah, that is also fine. That is also fine. Now it is moving to the slide number 8 and 9.
Mm-hmm.
Okay, fine.
Okay, so I was talking about that. This is how the social media is influencing the business. Now this doesn't end here. So you see, as I was going through that news in detail, so you see the WhatsApp uses signals encryption and so on. So that is fine. Now you see here 2 important things. So Reliance Digital is showing some as advertisement here, and most importantly, as I am living currently at Silchar, so here it is also showing another advertisement, let your Netflix experience in Silchar. Now I was looking at the news related to WhatsApp and the Signal related event. Now why come these things are visible to me? How these things are visible on my screen? How did they get this information? Like this Reliance Digital is showing me the refrigerator. It turns out that actually back in the last year, I was actually searching for the refrigerators, and I was going through Amazon or Flipkart for this, for purchasing of the refrigerators. Now that's why they might have captured these things, and they are now showing this advertisement to me, and from there also they actually captured my location as well. Another thing you can see, this is my personal Facebook account. So Facebook is nothing to do with the advertisement, but nowadays you'll see Facebook is also showing different advertisements, like this one. Flipkart is showing this refrigerators. The story I have already told why this is being shown to me. Now here another thing you can say, the Scam 1992, which is an web series. So this is also I was actually going through. So that they have captured. Actually in Sony Live there were only one episode that was free, but if you want to watch other episodes you have to subscribe. So I watched the first one, but they are now advertising the same thing to me, and so that I may in future I may subscribe to their same. So what are all these things? So these things are called advertisement, or we can say the targeted advertisement. They are actually targeting. So what I am doing on the social media or whatever activities I am performing on different browsers, they are capturing these things, and they are targeting my social media where I am using those, and they are advertising, or they might they might be sponsoring these things by the different social media, and these things are affecting obviously the business or the economy. Now this doesn't end here. You can see the health also. In healthcare also we are seeing the same thing. The COVID-19 situation you are already aware of. So you can see, so last January there were on live session, so which you can see actually where it is posted. It is posted in artificial intelligence, machine learning and deep learning group. So this is just one example. You'll find a lot of such examples. Now again in the Facebook you'll see different groups where that meant for different kinds of activities that users are performing. Like for example here the PhD or postdoc positions related to, that is again related to job, and IIT, NIT's placements and so on. These are different groups. So as per the interest of the users, they may find out their respective groups, and they will get respective information about those kind of things. Now again the another social media network we have the LinkedIn. LinkedIn is again related to job, and the ResearchGate is about the researchers publications and their questionnaires or discussions that can be performed. This is again research related social networks. And similarly we have Stack Overflow, so where the codings and different kinds of errors or different kinds of discussion related codings are there. So like that we have number of websites. So what all these things are doing, these are affecting not only our day to not only the health or education or employment or research. So if you see as a whole, it's actually affecting our all day-to-day event that are being that we go through. So it's actually creating like a virtual world, so where everything that we are in the real world network, real world scenario, so that are being actually affected virtually in the virtual world that is being created over the social network media or over the internet. So it appears if you don't exist or you are not active in the social media, you doesn't even exist for the rest of the world. Now the question is why the CSE people or any other domain people will be interested in doing research in this particular domain. Now earlier actually the social network study that we currently we are doing, so it was actually were in the offline medium, because then at that time there were no internet. Now currently we have every village or corners of the country are having the internet facility available. So now the social media platforms that we are having, with this we have the ability to
Okay, so Anupam, are you there? We just lost net connection for a short period of time. We'll just see what we can connect or not soon. We lost the connection of the speaker. Okay. Okay, so we have the connection again. Please share the slides.
Sorry, I don't know which slide actually it happened. Yeah. Can I continue?
Yes, sir.
Yeah. So the opinion mining, yeah. Somebody is saying, fine. So why CSC people are interested? Earlier, the social media that we have currently, that kind of medium were not there. So the social network study were limited to offline studies, so which mostly were done by the sociology peoples, and they were engaged in doing different kinds of research related to social networks. And nowadays, so we have the internet, availability of internet in the village, as a different parts of the country, and the social media platforms are also available to people. So this gives us huge amount of data. So that is being generated by different users by their different activities or sharing different kinds of informations over the social platform. So whenever there is a data, so with computer science people can do many things there. So, for instance, the data that we gather from different social media, so we need to process those. So therefore, we need different efficient processing algorithms, as well as to analyze those algorithms, those data. We require different algorithms to perform different tasks. And here comes the machine learning. Here the machine learning comes into the picture. Now, this in the social network, there are different problems. So like the opinion mining or sentiment analysis or the advertisement, these are not limited to this only 4 to 5 problems. There are a number of problems. So I'll be just focusing on these talks on the opinion or review mining or the sentiment analysis, and how we can engage the community detection or grouping in this scenario. So that will be focus of my talk. Now, what is opinion mining? The term opinion mining is tells us the procedure by which the information is extracted from the opinions or appraisals or emotions of people in regards to maybe different events or the entities or maybe different kinds of attributes. And those things not necessarily be in the social media, that can be in if it is an e-commerce site, there will be reviews of different kind of products or different blogs or maybe comments or articles. So all sorts of data that we generate or the users generate are actually textual, and what those things are all about. So what those things are telling. So whether it is a positive sense, is it giving the positive sense or negative sense? So those things is the objective to find the positiveness or negativeness of different opinions that different users are sharing through different mediums. Then what are the components, main components of opinion mining? So there are mainly 3 components. One is called opinion holder. So it is the holder of a particular opinion. It may be the person or an organization that holds that opinion. So who has shared the information. So maybe that person, or it may be the organization which shares that information. Then the opinion object. So about which thing it is the opinion is about. So that object is also very important. Then the opinion orientation. It determines whether the opinion of an opinion holder is about the object is if it is a positive or negative or neutral. So here comes into the picture the social or sentiment analysis. So I'll go through that later. So let's just concentrate on the opinion mining. So here is an example. So the scenario is that the James bought an iPhone a few days ago, and he expressed his opinion as it was such a nice phone. The touch screen was really cool. The voice quality was clear too. Now here, if you see, what will be the opinion holder? So obviously the James who bought the iPhone. So that person will be the opinion holder. And opinion object. So the voice quality, so that is about the iPhone. So he persist. So he's talking about the voice quality, that will be the opinion object, and whether he is talking about this in positive sense or negative sense. So in this case, he has a excellent word. Word excellent. Okay, so there is no word excellent here. So it is clear that the sense of this opinion is positive, as it is saying that quality was clear to or really cool. So these are the positive words. As we'll go through the sentiment analysis, we'll see in more detail. So what these words or senti words, how this can be used to determine the opinion of a or orientation of opinion of a person. So there are three major stages of opinion mining. So first of all, the first stage is data collection and pre-processing, then classification and aggregation and presentation of the result. So in the data collection phase, obviously the user who are generating, or the organization who are sharing their views about something, so those kind of data will have to collect, and the main task is to that everything there will be there in the document or in the opinion that is being shared by the user, so that everything will not be important for the extraction of opinions. So those things has to be eliminated. So that is the first and foremost pre-processing task as far as opinion mining is concerned. Then comes once we segregate or extract the important informations, so which is relevant for the opinion of a person. So there our objective is to find, so who will be the opinion holder and what will be the objective opinion object, and what is the sense, so what is the sentiment or the orientation of the opinion. So second task is to find the classification phase, so where we will be focusing on the sentiment of the statement. So that is given by different kinds of senti words that are being used in the opinion, and normally classification algorithms are used for that, like supervised or unsupervised algorithms. So unsupervised algorithm, we don't require training. For supervised, we require training. And since this opinion says, if we consider the political events, obviously that's training model, that kind of training model we cannot use for review mining. So it should be domain specific. So otherwise the model will not work. Then comes the third phase, that is aggregation and presentation of results. At this stage, results obtained in the previous stage, that is sentiment analysis. Once we analyze, then we have to aggregate those information and finally give the results, maybe in the textual form or in the graphical form. Now you have already noticed that in opinion mining, so sentiment analysis is very important. So the opinion that we are analyzing or extracting from the information that we have, so the orientation of information is very, very important. Now that is we are referring as sentiment analysis. So sentiment analysis is a kind of data mining where you measure we measure the inclination of people's opinion. So how we will be doing? We'll be using NLP or text analytics techniques or computational linguistic techniques for doing that. And we perform sentiment analysis mostly on public reviews, social media platforms, or similar kinds of sites that I have already shown to you. Now, normally 3 kinds of orientation we normally focus. That is positive, whether it is a positive or it is negative information or neutral. Another kind of information we often face, that is sarcasm. So it is, we cannot say whether it is a positive, negative, but actually, although it is a positive sense, positively saying, but actual sense is that it is actually a negative statement. So those kind of statements is categorized as sarcasm. So sentiment analysis, you see here is an example. So negative statement like totally dissatisfied with the service, worst customer service. So here dissatisfied word or worst customer. So worst word that is telling us the negative or giving us the negative sense. So therefore this opinion will say that it is a negative sentiment. It is having negative orientation. Then neutral. So you see here is an example. I've shown that good job, but I'll expect a lot more in the future. So it is neutral. Neither it is saying negative, but it is also not saying positive either. Then last one, the brilliant effort, guys. Loved your works. So completely this is a positive statement. So like that, these statements or the opinions that were given by the users, so we'll be classifying into 3 categories: negative, neutral, or positive. Now when we say sentiment analysis, so it actually involves cognitive science. So we have to sense from the textual information that we have, whether it is a positive or negative. So there comes the cognitive science. Then how we'll be doing? Obviously the computational or automated process will be doing. So for that will require the machine learning. Then obviously the information that we are having, those will be in textual form. Therefore natural language processing techniques are also have to be used there. There are 3 levels of sentiment analysis. One is called document level, or the articles. So where the information about any event or any object is given. So maybe you can consider this sentence level, not considering the entire document. You can simply consider or concentrate on single sentence. Or maybe we can focus on phrase level, so or word or aspect level. So in the document level, as I was saying, the whole document is considered. So in that document, there may be multiple sentences which actually maybe it will be oriented towards either positive, or some will be towards the negative, or some will be towards neutral, or maybe some will be also sarcasm kinds of thing. So all those things will be considered, and as a whole or overall there will be one orientation that will be given from that document level. So if it is a document level sentiment, so overall orientation of the document will be given. Then sentence level. So sentence level simply will consider one particular sentence from that document. Obviously during pre-processing, as I was talking earlier, so obviously during pre-processing we will be eliminating all those unnecessary information. We'll have only important information that is relevant to relevant for opinion mining. So those kind of information we'll have, and from there we'll be considering the sentences. Then at the phrase level, so that is Actually, sentence level is also there, but phrase level or if you consider only word, so those are very in-depth. So we'll have to look into what kind of words we'll be focusing. Generally, say we consider that adjectives, says for example, the lovely, nice, beautiful, amazing, old, bad, horrible. These are the objectives we may focus. So based on that, we'll be determining the orientation of the document or the statement. Then adverbs, quickly, slowly. So those are important, but the adjectives are actually playing a major role here. Then some verbs, they like, hate, love, despise. Sometimes also nouns are also used, like trust, junk. These are negative words, so which means negative sentiment. So if those are used in some sentences or in some documents, so we can easily conclude that those are negative or oriented towards negative statement, negative sentiment. So there are different kinds of sentiment analysis methods. So mainly those are categorized into two: machine learning approach or lexicon based analysis. So this will be computational linguistics techniques will be used there, like dictionary based approach we have. So we'll have different dictionaries and those will be used. And then corpus based, where the statistical or semantic analysis will be performed to finally get the sentiment of the statement. Then machine learning will have two kinds of techniques. You know that either it will be supervised and unsupervised. If it is supervised, we'll require to train those. So in supervised, there are different techniques available, like decision tree classifiers, linear classifiers, rule-based classifiers, probabilistic approach. So in linear classifiers, again, we have a support vector machine, then neural network. Nowadays, neural network is very popular. Different deep learning models like LSTM are immensely used for this purpose. Now, how the sentiment analysis works? So whichever technique we use or whichever approach we follow, exactly how the sentiment analysis actually works, how the machine actually will do these things. So normally, if we see if we see any statements or if we hear any statement, how do we figure out that this particular statement is negative or positive? So obviously based on some words. So for example, that tree is ugly. So ugly here is a positive word, not positive, is a negative word. Then the flower smells nice. It's a positive word. So like that, we'll have to give this thing or give this information to our model. So whether we follow the supervised model or unsupervised model, this information we will have to give to our model. Now, so it seems that the words, those are giving some intuitive information about the statement. So like say in this case, ugly, nice, and other similar kinds of words that we often use in our statements, those words are very, very important. Therefore, and those words, how much those are tilted towards or oriented towards negative or positive. So those words are already prepared as a database, which is referred as SentiWordNet. So which is an opinion lexicon derived from WordNet database, where each term is associated with a numerical score indicating the positive and negative sentiment about the information. So this is the triangle, so which shows us if we place any word. So in this case, so that word, the value, corresponding value will indicate us that whether that particular word is negative or positive. So currently we have SentiWordNet of about 150 in 115,000 words. So that is called SentiWordNet version 3. So here actually these things are already done. So whenever we require to analyze sentiment of any statement or any document, so we just have to use this or feed this information into our model. Then what are the challenges? So automated system cannot differentiate the sarcasm, so which is very, very important. Because we as a user or as a human being, we can easily read those information, and we can easily understand that whether that particular statement is a sarcasm or actually it is a positive statement or negative statement. Also again, different symbols, which also or some abbreviations, which we normal human we can we can easily understand, like for example lol. So these kinds of abbreviation we can interpret easily, but machines cannot interpret easily those things. We have to explicitly give these kinds of information to to our models. Then mixed opinions, such as some of the statements will have positive as well as negative. We cannot really classify those, whether those statements will be positive or negative. For example, I like the printer quality, but the size is too big. So it contains both positive as well as negative. So in that case, it is difficult to classify this. So also it is also unlikely that an automated system could identify bias or fake reviews. So somebody can give fake reviews also. So those things are very, very difficult. Now all these things, obviously we are living in the social media age. So as I have already shown that the social media as a whole lot of virtual world is being created. So therefore, obviously, whatever opinion we carry about any event or any object, so that will have influence of the people around us, right? So therefore, so if we come into if we are in touch with some group of peoples which are oriented towards a particular or have certain views about certain thing, so obviously that kind of view we may also get influenced by those. So therefore, the grouping of the people, so that also very, very important, as if we want to analyze the sentiment or say opinion, so from where those statements are coming and how people will act, or what kind of opinion will people will give for a particular event, so that we can predict early, if we have this kind of information, that what kind of grouping he is involving in and what kind of people he is sharing the information or participating in discussions. So there comes the identification of grouping, so which we call in social network as community detection. So in community detection problem, the main objective of community detection is that so what we'll be doing is we simply will group the peoples which normally in social media will be the users. And if we see graph representation, will simply that will be the nodes in the graph. So what we'll be doing in community detection problem is that we'll be grouping those nodes in the network by considering following two objectives. So first objective is that connection or connectivity within the group should be high and connectivity among the groups should be low. So these are the two main objectives. So you may find it is more or less same as clustering, normal clustering that we do. So similarity within the cluster should be high, similarity among the cluster should be low. Same concept is being used. Just only one thing here is that the similarity is defined by on the basis of connectivity or the relationships that we are having. So often those things are referred as community or clusters or modules. So this means the same thing, just the interpretation will be in terms of links or connectivity among the users. Now, what kind of communities do we identify? There are two major categories. One is called disjoint or non-overlapping. So where the node will have membership of only one community, or he may belong to only one community, and the overlapped. Here the member may get the membership of two or more different communities. So again, in the overlapping, we have two kinds of overlapping. One is called fuzzy overlap, another one is called kiss overlap. In the fuzzy overlap, if the membership is there, it will be it will be on the shared basis, or in the case of kiss overlap, so if there is a membership, it will be full membership. So in fuzzy overlapping, it will be on fractional. It may be say 1/10 for one particular group, or 9/10 will be for another particular group. But in the case of kiss overlapping, so it will be full. So if it is a member, if a particular node is a member of a particular group, it will be full membership. Now, there are different kinds of issues that arise during community detection. Mainly is the assurance of quality and accuracy. So as you can see, this community identification, so which is nothing but a clustering process. So obviously it will be a unsupervised process. So therefore, the assurance of quality and accuracy is very, very important, and it is very difficult too. Then diverse kinds of networks. Why diverse kinds of networks? You can see there are different kinds of platforms. Same person may be in the Twitter as well as Instagram, or in the Facebook, or in the Twitter, or maybe in the different other social media like LinkedIn or YouTube, or maybe in the say ResearchGate. So all these kinds of platforms are there. To cross platform, we have different kinds of users, and they are performing different kinds of tasks over different kinds of platforms. So there are diverse kinds of networks, and cross platforms are there. So in those cases, considering those scenarios, how will we identifying the groups? Thirdly, once we identify, how do we validate whether our communities that has been identified, whether those are actually valid community? So how do we identify those? So I'll be going through all these issues briefly. Now, what kind of techniques are there are available for community detection? So there are 4 major techniques that are being used: hierarchical approaches, then spectral clustering, optimization techniques, then statistical interference. Not interference, it's statistical inference. Hierarchical approaches are again subdivided into 2 categories: agglomerative approaches and divisive approaches. Then optimization techniques, mostly the modularity maximization techniques are used. Then some heuristic approaches like genetic algorithm, particle swarm optimization algorithms, those are being used. So obviously it is not possible to go through all those techniques. Still, I'll try to cover all these techniques. Mostly most likely I'll be discussing the one agglomerative algorithm in detail and another heuristic algorithm, so you can get the idea so how this techniques actually works. The hierarchical approach, as I was saying, there are 2 categories: divisive approach and agglomerative approach. In divisive approach, it is called a top-down approach. So this is the network, say we have, and this network, from this network we'll have to identify the different groups. So for that, so in divisive approach, what we'll be doing is we will be starting from the network, entire network. So here we are considering the entire network, the nodes we are considering as a single community. Then we gradually remove some of the edges. So like here you can see we are removing, say, edge number 4, 5 and 4, 6, 4, 5 and 4, 6. So these two edges are removed. So clearly we are left with two groups, these groups, this one and left side this one. So again from this group, again we say remove this 9 and edge 9, 7. So this will give us this community and this one another community. So thus we'll left with 3 communities. Now how we are removing or how we are deciding these edges. So for removal, this technique is actually Greven-Newman approach. So here actually edge betweenness is considered for deciding which particular edge will be considered for removal. So edge betweenness tells us, so if you consider all pair of paths, and how many of those paths are actually passes through this particular edge, so that will give us the edge betweenness of this particular path. So likewise we'll measure the edge betweenness of all paths, and whichever path, whichever edge will have highest edge betweenness, those will be removed, because those edges actually will act as bridge between two groups. So therefore removal of those edges will give us the clusters. Then comes the agglomerative approach. So here, which is also referred as bottom-up approach. So unlike top-down approach, where we consider the entire network and then we try to divide those network into different groups. So here we'll start from the bottom, meaning we'll start from the nodes and will gradually add up those nodes to form different groups. For example, here, say this is the dendrogram. So again, dendrogram is also will be prepared based on some properties. Like here, it is used modularity property. So what is modularity? I'll be showing the formula for modularity. So the modularity tells us the extent to which a particular node will belong to a particular community. Now, how that will be done? So as you will go through the formula, you will get why I'm saying that. Now, so based on modularity, so what we'll be doing, we will be just merging or adding two different nodes into one single community. Like this process will continue, and these labels you see. So these labels actually, if we stop here, so it will give us, say, 1, 2, 3, 4, 5, 6 communities will give. So if we stop here, it will give us 2 communities. Like that, we can decide how many communities we want. So this is all about the divisive and agglomerative approaches. Now I'll discuss another algorithm in detail, which is called Eigenbase community detection, which actually follows this agglomerative approach, but it a slight different way. So as I will go through the technique, algorithm, it will be clear to you. Now, background knowledge will be required before I can go into that algorithm. So one thing you will require to understand is the ego network, then mutual interest in the relationship, then network properties and level of abstraction. Then 2 properties are there, so that I'll discuss. That is called isolability and reachability. Now, what is ego network? Ego network is a person-centric network. So for instance, if I want to prepare my ego network, so who will be my ego network, who will be in my ego network, that is the friends, immediate friends or immediate colleagues that I am having. So for instance here, the person at the center is called ego, and immediate neighbor or the immediate friend, a close friend, will be considered as alter. Now, if we consider friend of friend, then that will be again another alter. So likewise, this will grow and it will form a snowball kind of structure. So now this example here I have shown here the level 1 ego, meaning that we are just concentrating on level 1 friends, and we are not considering the connection between the or among the friends also. So we are just considering the connections from ego to alter. Then the mutual interest in the relationship, you know, so any kind of relationship that we talk, so obviously both persons engaged in that relationship should have equal share. So if we consider the ego, so if in that case the interest of ego, we are saying it is a forward interest that is having the relationship with the alter, and for alter, if it is having the interest in that relationship, then we'll refer it as backward interest. So if we have both backward and forward interest, then only this relationship will be stronger. So this is a social property. So obviously, if relationship between any two person needs to be stronger, then obviously involvement of both the persons should be there. Otherwise, the relationship will not sustain. So similar concept will be used in this particular algorithm. Now, there are different kinds of network properties. So there are so we have network level properties like we have CART, normalized CART, conductance, modularity. So these things are defined on the basis of the nodes that are all entire network basically considered to define this kind of property. So other properties like group level, so where instead of considering entire network, we will be concentrating on a particular set of nodes or subgraph of the network. And the node level property, which obviously it will be based on nodes, but it will involve the maybe the immediate neighbors. So which will be clear to you as I go through the properties. Say for instance, this is the reachability property. This is a node level property where the node reachability measures the reachability of say node R into a community C, meaning that how likely the node will belong to the community C. So which is given by this formula. The numerator tells us the neighbors that are neighbors of R that are already there in the community, and denominator tells us the actual neighbors, the number of neighbors. So these are the strength of that particular edge that connects those neighbors. So normally, if we consider the adjacency matrix representation, if it is a unweighted graph, if we represent the network as an unweighted graph, simply it will be 1. So this will just give us count of number of neighbors. But if we consider the weighted graph, then in that case it will be the relationship strength. Then isolability, it is isolability, again another property that is a group level property. So this tells us how likely a particular group is able to isolate the group itself from rest of the network. So meaning that, for example, if you consider this is the this is the group, or this is the group, so how likely this particular group will would like to isolate itself from the rest of the network, meaning that if it has a higher number of connection with the rest of the network, obviously it will this particular group, we cannot say that it is a standalone group. If it doesn't have enough number of connections and it has enough number of connection within the nodes that are there in the group, so then only this group can sustain. So this formula actually measures that thing. So you can see in the numerator we have the strength of the nodes that are there in the network and connections there among the nodes that are there in the group, and in the denominator we have the connections that are there with the group plus the number of connections that are having with other part of the network. So for instance, if you consider this group, we will have this in the denominator, this connections, and in the numerator we will have this connection plus these inter-community connections. So basically in the denominator we will be considering the intra-community connection as well as inter-community connection, and in the numerator we will have only intra-community connections. Now, with this, we can define the community structure as follows. So, given a network or a graph, say graph VE with V nodes and E connections, a subgraph that is C with E edges is called a community C if it satisfies the following. So, following property, the number one is the node level property. So that means if it has at least alpha amount of visibility to C, so then we'll say that that particular node that is there in the C actually belongs to that community. Then property 2, it tells community level. So we have just now seen. So if a community has at least beta amount of isolability with rest of the network, then only that community can sustain. So with this we can say that so if a community having alpha and beta amount of reachability and isolability respectively, then we'll say that that is a valid community or it will lead to a community. Now with this initial knowledge about the different properties and the concepts that are being used, so I'll just go through the algorithm. Algorithm has two main phases. One is called expansion phase. So where what we'll be doing is mainly there are two tasks will be performed in the expansion phase. So first task is to identify the community and second task is to expand the identified community. So we can start from any node. So as we do in the algorithm agglomerative approach, so we'll start with any particular node and we will gradually add the nodes for expansion of the community. And obviously during inclusion of these additional nodes, we will be following or using the reachability property to find the reachability of a particular node to that particular node community. Then after expansion phase is over, that means we are already done with the identifying their respective communities. But then we have to ensure the isolability of the community. Therefore, we have second phase. Here, the communities that are identified in the expansion phase will be revisited, and then we'll verify their isolability. If their isolability, the identified communities are having less isolability or lesser than the threshold set, then in that case we'll dissolve those communities to appropriate other communities, verifying their reachability. Now how it is being done, it is given in this algorithm. I will not go through the every steps. So if you are interested, you can go through this algorithm. So this is the dissolution phase. Then after this algorithm, we'll be left with or will get the outcome as a communities. So this is say communities we have obtained from the network called football network. So there are 12 communities in the football network. So say our algorithm has identified this. Now, as I was saying, the evaluation of communities, so that is very, very important. So how do we ensure the communities that has been identified by the algorithm, whether it is a valid community, or say how the quality of the communities that are being identified, whether it is a accurate one or the quality wise it is good. So accuracy and quality are two different things. When we say accuracy, so we'll require ground truth of the community, and when we want to measure the quality, we will look for the topology of the network. That means it will involve the connections in the network. Now for evaluation, different measures are there. So one popular measure is called adjusted rand index, or ARI. So this is the formula. So again, different terms are there. So this is related to the community that has been identified and the ground truth communities. So this is the R is the real community and C is the actual community. So different terms you can see here. So I'll not go into the detail of this parameters. Then another measure is called normalized mutual information, or NMI. So it is a information theoretic approach where the community that are there, or the ground truth, or maybe in the the identified communities by different algorithms, so which will be considered as a distribution, probability distribution or data distribution. Then from there, the shared information or probability will be counted with this formula. Then the purity is another formula that is being used, so which is very simple. So which just considers only correctly assigned nodes to a particular community. Then F measure, I suppose you all know the F measure. So how it is being measured? So it is nothing but the harmonic mean of two things, that is called precision and recall. Sometimes it's also referred as F score or F1 score. So precision recall will require the confusion matrix. So from this confusion matrix, so that's why I was telling that it requires ground truth. So obviously for every network, we don't have we can't have the ground truths. So therefore we have to rely on the connections or connectivity or relationships that we can generate, or we can interpret from the data that we have. So there comes the quality measure. So as I was telling, the modularity is very, very popular. So so mostly the modularity is used wherever the community detection algorithms are being used to measure the quality of the community. Then another measure is called coverage. So coverage of any clustering or community is the fraction of edges that connect two nodes of the same community with total number of edges present in the network. The coverage can be computed with this formula, simple formula. Then external density tells how many connections are there, just to measure the inter-community connections. So obviously, to have better community, we should have less inter-community connections. So external density measures there. Then different data sets. I didn't show the data sets of text opinion mining or sentiment analysis because it involves the NLP, so it already have. So those who work, you already know. So I'm just showing the network related data from where you can gather this information, like SNAP database, which is get resource for this. Then Kaggle forum, you will get some of the data sets, and then network repository, then UCI repository, then LFR graphs. If if you're not satisfied with these datasets, you can also generate your own datasets. A synthetic network you can generate as per the requirement of your analysis. Then obviously one very important thing is that if your algorithm has different parameters, so you need to tune. So like in this algorithm that we have just now discussed, so it has two parameters, alpha and beta. So so different networks, we can simply get the different measures, and we can plot in 2D form, and we can easily get which particular combination of these parameters actually gives better results. For instance, you can see alpha value 3 to 4, actually it is giving higher coverage value. Beta also from 8 to 7, it is giving higher values. So likewise, other external density, as I was telling, so this should be low. So why? Because inter-community connection should be low. So the external density measures that. So therefore, obviously, this measure should be low. So you can see the alpha value again from 3 to 4 range. It gives lesser external density, and for beta value also again 6 to 7. So overall, we can conclude that from this. So similar results you can see for others also, other metric also. So from this we can conclude that alpha value should be ranged between 3 to 4, and beta value should be ranged from 6 to 7. Now different results, different algorithms. Obviously, we have to compare different algorithms to verify or justify our claim that if we develop our new algorithm, so whether it is performing better. So here we are comparing, say, 6-7 algorithms. So you can see different measures. So we can go through these measures and we can just say that which particular algorithm is performing better. So these are some small networks. So these are the results on some large network. Now with this approach, you can see there are different measures are there. So here some are if some are high value, those will indicate better. If some are low value, least value, then those will indicate the better performance. So obviously, if we consider multiple such numbers, as we have already observed in the case of sentiment analysis, in some statements, so both positive as well as negative statements are there. So if in that case we cannot decide whether it is a negative or positive sentiment. So similar trade-off will face during evaluations also. So say some measures actually that gives higher accuracy value, but they may give less quality, and that is obvious because accuracy is measured based on the ground truth, but the quality is measured based on the connectivity. So there is no correlation between this connectivity as well as the ground truth. So therefore, this trade-off is quite intuitive. Now, how do we deal with this? How do we accumulate these different results that we may get from different measures? How do we accumulate that? So there is a technique called multiple criterion decision making. So simply this considers all these measures and gives one common or overall relative score of performance of an algorithm. So this techniques again, with this technique, it is also difficult that whether a particular algorithm is likely to produce accurate community or high quality community. So that we cannot say from this, although we can rank those algorithms with these scores. So therefore, so there is a technique called Gita Analysis. So that overcomes this. So let's just go through the Mctm process, how it works. So it takes a decision matrix M as input, where we'll have M rows for criterion, so which will be metric that we have just now shown, different metrics. Then N rows, So which will be multiple alternatives is nothing but the algorithms that we are planning to compare. To generate the MCTM score, so there are different algorithms already available. So, so you can simply consider the TOPSIS algorithm, which is very popular technique for order preference by similarity to ideal solution. So it simply ranks those algorithms and gives the performance of the algorithm. Now, as I was saying, this measure, although we can rank easily, but it actually doesn't tell, or it cannot tell about an algorithm whether it is inclined towards accuracy measure or towards quality measure. So for that, there is a technique called Gita Analysis, relative inclination towards accuracy. So what it does is, this is the simple method. So simply what it does is, simply we assign the weight to different accuracy measures, and will relatively give weights to quality measures as well. So as we gradually increase the weight of accuracy, we will gradually decrease the weight of the quality metrics. Now, how do we use these things for measuring the inclination? So here is an example. So for instance, we want to analyze the inclination of a particular algorithm. Say we are considering these 5 algorithms. Now you can see as we gradually increase the accuracy weight, so MCTM score, obviously if we increasing, so accuracy, if it is inclined towards accuracy, it should increase, right? So now you can see for CFGC, it is actually declining. So if we are giving more weight, it is supposed to be increased, but it is not increasing. Instead, it is decreasing. So like that, you can see another algorithm here, that is Fajek algorithm. So it is actually increasing. So other algorithms like FMM and say MDP. So also you can see it is also increasing. So like that, we can see other performance. So it is clear from this that if an algorithm is having high MCTM score and it is gradually increasing, once we increase the accuracy weights, then we can say it is inclined towards accuracy, meaning that we can say that, or we can interpret that the algorithm is likely to produce accurate results. So here is the overall indications which we can consider. So for instance, if accuracy is high and quality is also high, and accuracy is stronger is accuracy, meaning that accuracy values are higher in comparison to the quality, then the curve that we have just now shown, if it is increasing, then and also this curve is high, then we'll say it has high accuracy. So you can see only 2 cases this happens, otherwise it actually doesn't happen. So this is very important, because most of the cases the accuracy, ground truths are not available, so we cannot measure accuracy. If we can alternatively ensure the accuracy of an algorithm, so which will be very important for the community detection algorithm. Now, that algorithm that we have just now shown, this algorithm actually tells about how we can use the agglomerative approach, and how we can measure those algorithms, and how we can ensure the accuracy as well as quality with this kind of analysis. Now, another issue I mentioned was the network diversity. So so a network may not have only one link, like simple graph that we have earlier shown. So why? Because a person may have interest in say football. He may also like to play some instruments, or maybe interested in doing some different things. So obviously, so you cannot consider the relationships between any 2 persons as just only single link. So for instance, here, say if a person likes say music, and another person also likes similar kinds of music, so we can say that these 2 persons are linked in some way based on their interest. So likewise, what we have just drawn here, say we are considering the all such attributes, like all such interest of a person, and we consider all the persons that are there in the network. Then simply if a person is having similar interest, we will just connect those. So like here, for example, say if I consider say person 1 and person 2 with in terms of attribute 1, so we'll just connect these two nodes, two attributes, on the basis of their interest in reference to the attribute A1. So again, for say if I consider attribute 2 for the same two persons, you can see this entry is 0 because this doesn't like that particular attribute or are not interested in that particular attribute. Like that, we prepare say this kind of matrix, so which gives the preference of a person. Now with this we can see that there are multiple relationships among the persons and multiple networks are there, and how we can now identify the communities or group, how we can form the groups if such kinds of relationships are there in the network. So simple, the representation we have already shown here. So what we can do, we'll just here actually the optimization techniques like heuristic optimization techniques like GA, particle swarm optimization, and other algorithms can be used. Why? Because we can simply form the or represent the solution in the form of groups, and we can simply plug in into the algorithm, and we'll and also we will have to define the objective function. So we have already seen the objective of a community detection problem. So that is there will be two objectives. We'll have to ensure the highest connectivity or maximum connectivity among the among nodes among the community, and least connectivity among the community and highest connectivity within the community. So this objective we have to fulfill. So to plug in the heuristic approach, say we want to plug in the particle swarm optimization algorithm, what we'll simply do, we just encode this into a particle. Suppose we have n instances containing m features, and we want to group them into k communities. Then we'll simply place into a single particle. So how we'll be doing that? Here is an example I have shown here. So say this is a particle, so we'll just consider all the attributes here. If you consider say k communities will be representing each of the communities as this, and in this we'll have different kinds of attributes that we are considering in respect to that community. So like this, we'll prepare the representation of a particle. Now the next task is to define the fitness function. So to define the fitness function, here have used a simple Davis-Baldwin index, so which was defined in 1979. The index simply measures the quality of a community. So meaning that, as I was telling, so simply it will consider the connectivity within the community to measure the quality of the community. Now, how this connectivity is considered? Simply, this considers Euclidean distance, because we have defined already this as different values. As once if it has interest, if it doesn't have interest, it will just 0. So simply you can perform the Euclidean distance. So this by simply gives the quality of a single community. Now if we consider say k communities, obviously we have to combine all this. So simply what we're doing is simply adding those up and taking average of that. And this gives us the fitness function for the community detection. Next, we have defined already the particle, as well as, that means the representation of the solution, and as well as the fitness function. So we now we have to now simply plug into the particle swarm optimization techniques. So PSO algorithm you might have already aware of. Simply we'll plug in there, and wherever we require to compute the fitness function, we'll just compute that. Now we have compared those the results with different variants of particle swarm optimization. Actually, we have observed that the four variants that we had considered, actually this shows almost same results, but only difference is that their execution time. If you see execution time, PSSCA takes much lesser time. So otherwise, the quality wise, the communities that were identified by different variants of particle swarm optimization algorithm, actually those give same results. So with this, we come to the end of the talk. So in summary, so what we have discussed is how the social media influences our day-to-day life. We have discussed the NLP in the social media analytics, the opinion mining and sentiment analysis techniques that actually involves the NLP techniques. Now, then we have seen how the community detection may also add on to this opinion mining or sentiment analysis, and how we can detect different communities with different techniques. So we have discussed two main measure techniques, that is agglomerative approach. One algorithm we have discussed in detail, and another technique is on heuristic basis, that is PSO based algorithm. Then we have explained the evaluation measures and the data analysis techniques for the community detection techniques. Thank you. If you have any queries, you can ask.
Sophie?
Yes, sir.
Okay.
So participants, anyone is having any questions? Can go ahead.
Any questions from the participants? So, if there's no question, then let's thank the speaker once again for a wonderful talk and giving his valuable time for the event. And we are going to start our online exam at 2:40. That means we are going to have 10 minutes break after this talk, and I will be sending the Google form link. It is of MCQ to your registered mail IDs, and you will be finishing this online exam in 45 minutes, and at 3:25 we will be closing the response acceptance at the Google form. So we will have a 10 minutes break, and then I will be sending you the Google form link for the online exam, and you can start filling out the form and then submit. Okay, thank you. We will have 10 minutes break.